So our next speaker is Peter Andrews, who is a farmer and horse breeder and is best known as the founder of natural sequence farming, which he tells me is a descriptive name for the efficiencies of the Australian landscape, and I'm sure he'll explain what he means by that. He argues that Australia was originally a fertile and healthy landscape, and one of the evidentiary bases is the existence of megafauna here, but obviously over many thousands of years that's changed. So Peter advises on natural sequence farming. He's written 2 books on it, and he's going to tell us more about it.
Well, thank you very much. I guess we've heard plenty of science today, and it's convincing science. It's real science. It's science based on absolute fact and ability to make relevant decisions on the fact. And of course, when we look at the CO2 part of the argument, we know that that can't be fact. That in fact, it's an extrapolation from a model. And of course, my frustration was I went into this landscape and I've lived through some completely different areas of the landscape where it went to desert in 3 hours when I was quite a young boy. And it was horrendous for 2 years. And I was old enough to remember that in fact the climate changed in those 3 hours completely. It went from everything you've heard today, extremely hot days, very cold nights, massive thermal windstorms, and then after this 2-year period, we had a fortunate 15 points of rain. 10 days later, it rained 1 inch and a bit overnight. And I came outside in the morning and it was green again. Now it wasn't the rain overnight that made it green, it was the 15 points 10 days before that allowed this landscape to trigger its amazing recovery mechanisms. And so the experience was then, the climate changed again completely. What's wrong with our ability to understand that this is possible, that this actually happens? And that in fact, I put a photograph up there that 3 years before, that was pretty much an arid creek flow system. And we've got a landscape with long hours of sunlight and systems and plants that can absolutely multiply landscape productivity in a really short time. And all I'm going to concentrate in talking to you people is the exercise of basic common sense and the capacity to know that this is not witchcraft or anything else. It's a fundamental function of a landscape. And here we have, in my opinion, and let me tell you, I have had this international reference panel supporting really analysing whether in fact what I'm talking about is rubbish or whether in fact it's based on real science. So I was quite happy to jump up and say, yes, it's based on real science. And that in fact we can make complete calculations. We can measure how much carbon is in a forest, how much is in the soil and was in the soil. And then we know that if we do things like take those areas, respecting Mr. Ripple's feedback loops, because we must, and recognise that it is a dynamic system, that if we don't understand the relationships between those dynamic aspects of the system, we'll wreck it. But this is the opportunity we have. This Australian landscape goes from the tropics to the temperate zone. And a valley floodplain system of the Murray-Darling extends through all those regions. Now I've travelled extensively. I did 150,000 kilometres after I had gone into a catchment and seen a miniature of how these landscapes firstly can be completely destroyed and secondly how they can recover. The Hunter Valley was originally occupied somewhere around 1822, and by 1900 it had been so overused that a flood system then took every tree out of the Hunter River from more or less Denman to the coast. Again in 1920-something, and again in the 1950s. And so here we had a landscape with sandstone cliffs and little catchments in it that were just replacement materials of sandstone. So most people would have to recognise that that is some of the poorest potentially land recoverable process that we could have. There you go, some old goat standing in a bit of grass. But this area, just 3 months before that photograph was taken, was a flood, the biggest in 100 years, 2007. And these plants, which they're not native, and these is the bloke standing in the middle of it, nor are the animals that he uses to make any money, nor any of the plants that he uses pretty much to make a commercial process in this landscape. So why are we talking about it's native or it's not native? Do you really expect that you're all going to leave, or that you're all going to take all these things that keep us alive away from this landscape? Because that's what you need to do if you want to talk native and non-native. The fact is, you're being told today that it's these feedback loops, it's the production of sun's energy and the drawing down of alcohol. You probably had a little bit of that as well, because it's a great carbon compound. But the bringing down of CO2 into things like your alcohol. So that in fact, that particular set of scientific data is without question. And we can do very simple things like, how much can we grow just on the surface as a visible thing, in how long? And see those plants? They take about 3 months, 2 months perhaps, to establish a little rosette stage. Then they go into an exponential growth cycle. And in 30 days, from something you wouldn't see in the grass to that. And then they're finished. 100% of that, what you can see, plus what's in the soil, which is equivalent pretty much to what's above, is available for immediate use once the microbes do their reprocessing. But the next issue is, in the soil, powered by sunlight, are all the sugars and the incubator that makes all Willie's microbes and all these little processes develop their feedback loops. If you walk away from this process, you've got major time frames to get it re-established. But here we've gone from sand, that was a sand nearly a metre deep, just 3 months before. And after that was recycled. It was grass, and it still is. Anyone can go there and look at these things. And of course, I'll jump around a little bit because I just want to show that that's a weir or a de-energising system that's in the Australian landscape. And in fact, as we knew that there was some management systems that must have failed very quickly when we upset the plants, these processes, and I'll show you, that's that same structure, it's a bridge, but under deep flood, you've got a situation where the water is very foamy there, you see, and this is where the intake is happening behind the bridge. The idea is that we speed up water till it gets to that area, and then this flood water that's going over the top is also becoming involved in that area. So what we've got now is a wave, some of Willie's energy sitting up there, and now what's happening, some water's coming back this way and going around like that. Accumulatively, below that, it's got to build its kinetic energy again. Now you'll see photographs, and I'm not going to go through it all at this stage, of Aboriginal paintings and paintings that we've done. And if any sort of engineers and scientists are prepared to go into the landscape, I'll show them how this pattern was right through our landscape in various forms. Its principle was to prevent this headwall erosion that's now taken off and destroying many parts of our landscape. Now we want to go back to the, I've got my issue of, one of the things that happened in that pile of water is that at the high watermark of that wave, the water stops moving because, as you know, there's a level plane influenced by gravity. And so if you put a wave in, or if you put a weir in, the water at that level stops moving. Same as if you had a tap and 5 miles away you turn the tap off. It stops 5 miles away. You pile of water with that bridge and it stops. See the line? That's very, very fine sediment. And it dropped out at the height of the flood, the top of the flood, not after the flood went down. So that water had lost its energy at the highest point of the flood in that zone. The water that still had the energy of the flow system was right on the top of all that. So what you're able to do, and what this landscape did, was create these roadways of still water on the ground next to the grass, and the big floods went over the top. Now, I have a statement that some engineers, and most probably, have a problem with, and even my good colleague, friend Willie, said to me, you can't say something has an unlimited capacity because most things have limits. But the fact is that if you can set this system up so that that groundwater is